Finkelstein, and I did my science project on evaluating and comparing mobile device charges as my experiment. I wanted to see if a cheaper charger works just as well as an expensive one. I tried to answer questions such as, are all chargers the same? Are cheaper chargers as good as more expensive ones? If I need my mobile device charged quickly, say at an airport, do I plug into a wall outlet, a USB port on my computer, or a charging station? Have you ever been in this situation where you are on a long car journey and you have your mobile phone plugged into the cigarette lighter in the car, but your phone continues to lose battery power as you're driving? This happens when you're using a car charger that provides too little power or amperage for your device. We can fix that by using a charger that provides enough amperage or power. But what is amperage? Well, an amp is a measure of how much electrical charge is passing to your phone. And you can measure this with an app. The higher the number of amps, the faster your device will charge. This probably looks familiar to you, a typical charging circuit. You have a wall outlet for power, charger, cord, and your mobile device. What we want to do is get the most power or amperage going into your device, so it will charge it faster. As long as you are using the proper charging device, it will provide 5 volts to your phone. But amperage can be different depending on the type of charger, and that's what I wanted to find out about in my experiment. As you can see by this slide, you have many options to purchase a charger. As you have many options for charging, you also have many different power sources. My experimental design was to learn in general about charging mobile devices. I downloaded the amperage app so I could measure current or the amperage going into the battery of my mobile device. Then I closed all the open apps of the mobile device to ensure a constant rate of loss was being shown on the screen of the amperage app. Then I labeled each of the 10 charger devices as shown in the pictures. I recorded the cost of each charger. I took 3 measurements for each charger using the amperage app and converted each measurement from milliamps to amps and put the data into a Microsoft Excel chart. I then calculated the average for each of the 3 measurements. I then took the ratio of the cost to recorded amps. I wanted to find out how much each charger costs to deliver per 1 amp to my mobile device. I then analyzed the data and came to my conclusions. This was the equipment I used: a computer, 10 different types of charging devices as shown in the previous pictures, my dad's car charging station in his car with a USB and a cigarette lighter, and the amperage amp, which was free on the Google Play storefront. Then I also used the computer for Microsoft PowerPoint and Excel, and of course my mobile device. I also used the website to convert milliamps to amps as shown in this picture. Safety is always important when doing an experiment, especially when you are working with electricity. So some of the safety guidelines I used are on this chart. My analysis showed some very interesting things as I graphed out the data. This chart shows the 10 devices I used in my experiment with the amperage each produced. Under each data point or bullet is the cost of the device. So, for example, if you look at the data point 1, which is the charger 1, the cost is $29.98 and produced a little over half an amp. By this chart you can see that the most of the charging devices were between 0.4 and 0.6 amps, no matter what the cost was. What's interesting was the most powerful way to charge was by using the computer USB port or the car USB port. And since those only require charging cord, those were also the cheapest way to charge. Now this next slide, I was able to break down the cost of each device by equating it to produce the same 1 amp per second. So this chart shows the cost of producing 1 amp per second for each of the 10 charging devices. You can clearly see that the car USB and computer USB provide the best value for charging. So my conclusion is that the most expensive chargers and the least expensive chargers really do not provide that much increase in amperage. Device 6 was pretty high at 0.7 amps at a fairly low cost of $12.95, and that was the red charger. But what I learned is that when you are near your computer, using the USB port is your best option, as it will give you the highest amount of amperage, and that will charge your device faster than using a wall outlet charging device. Or when you are in the car, use a USB port instead of the cigarette lighter. These are your best options, and then you don't have to purchase an expensive charging device. I hope you enjoyed my presentation. I'm always using my iPhone a lot, and now through science I have learned the best options for charging my iPhone faster. After all, happiness is a charged mobile phone, and doing it at a low cost makes me even happier.